All right, let's jump straight into this explainer on the absolute engineering marvel that is flying faster than sound. Today, we're going to take a really close look at a machine that completely pushed the boundaries of modern science. We'll be using the monumental triumphs and, well, the tragic vulnerabilities of the Concorde as our guide. It's an incredible story about how humanity engineered a way to literally beat the speed of sound, why we just suddenly stopped doing it, and how today's engineers are trying to bring the dream back to life.
To really appreciate the sheer scale of this engineering achievement, think about this. Normally, a standard passenger flight from Paris to New York is going to take you about 8 hours, right? But the supersonic Concorde, it could travel that exact same distance in just 3.5 hours. It's essentially like comparing a regular car to a bullet shot from a gun. It completely redefined what was physically possible for a commercial airliner, effectively cutting a massive transatlantic journey entirely in half. Because it was so insanely fast, the Concorde actually boasted this brilliant tagline, "Arrive before you leave," and it perfectly captures the audacity of the whole project. Because of the time zone difference between Europe and America, you literally landed at an earlier local time than when you took off. Mind-bending, right? But of course, this level of extreme engineering came with a pretty massive price tag. Flying on the Concorde was the ultimate luxury, a huge status symbol for politicians, sports stars, and celebrities. A single round-trip ticket costs around $12,000 back in the day, which, just to put that into perspective, translates to a staggering $20,000 in today's money.
Section 1. The physics of speed, breaking the barrier.
So, to understand how a machine can move this incredibly fast, we first need to break down how aviation actually categorizes speed. Standard aircraft sit very comfortably in the subsonic range, meaning they travel at less than the speed of sound, which at sea level is roughly 1,236 kilometers per hour. Now, if you're hovering right around the speed of sound, you're transonic. Once you break past that barrier, you enter the supersonic realm. And if you somehow push it to 5 times the speed of sound, well, then you hit hypersonic. Just for context, today's regular passenger jets cruise around 900 kilometers per hour, putting them very firmly in that everyday subsonic category.
The crucial thing to remember here is that the Concorde didn't just casually inch past the sound barrier. It completely shattered it. It cruised at roughly Mach 2.0, which is an astonishing 2,160 kilometers per hour. Mach is basically just the ratio of the aircraft's speed to the speed of sound. So the Concorde was flying at more than double the speed of your normal commercial jet. That is a staggering number, especially when you realize they were putting everyday civilians, not highly trained fighter pilots in G-suits, into a machine moving that fast.
But, as we know, physics dictates that speed has consequences. Whenever you break the sound barrier, you create what's known as a sonic boom. When normal jets fly, their sound waves sort of ripple and curve outwards. But at supersonic speeds, the plane is moving so fast that those sound waves actually begin overlapping with each other. And this overlap creates a massive, sharp sound that mimics thunder or a huge explosion for anyone standing on the ground below. It's kind of like bursting a highly pressurized balloon with a pin. All that pressure releases in an absolute instant, causing a massive, loud crack.
Section 2. Engineering the Concorde, designing for speed.
So how did engineers actually build a commercial jet to survive and thrive in these crazy supersonic conditions? Well, following a multi-billion-dollar agreement between Britain and France in 1962, the race was on to build a plane that could literally slice through the air with almost zero resistance. But engineers faced a massive dilemma. To fly at Mach 2.0, the plane absolutely needed a sharply pointed, needle-like nose for maximum aerodynamics. But a nose that long and pointed meant the pilots literally couldn't see the runway properly during takeoff and landing. So their ingenious solution? A mechanical nose that could drop, or droop, downwards to give pilots the visibility they needed near the ground, and then mechanically raise back up into a perfect aerodynamic spear when they were speeding up into the sky. It's just brilliant engineering.
Section 3. A fatal chain reaction, July 25, 2000.
The thing is, operating at these extreme speeds leaves absolutely zero margin for error. For over 25 years, the Concorde had an amazing, totally flawless safety record. People genuinely viewed it like the Titanic of the skies, prestigious and seemingly crash-proof. But that all unraveled due to a single, tiny variable. A plane taking off just prior had left a stray 17-inch piece of metal sitting on the runway. So first, as the Concorde sped up, it struck this metal piece, violently slashing its tire. Second, while the tire didn't completely puncture right away, small, extremely heavy fragments of the rubber were flung upward at an immense speed and slammed into the underside of the plane's left wing. Third, this extreme impact created a high-pressure shockwave inside the wing itself, which actually caused the fuel tank to burst from the inside out. And finally, with aviation fuel pouring out at high speeds, the incredible heat and the high RPMs of the aircraft's engines ignited that leaking fuel. An air traffic controller actually spotted the fire, but the plane was already moving way too fast to safely abort the takeoff.
In an absolute instant, the world's most prestigious and seemingly invincible aircraft was brought down. The pilots lost all control, and the plane tragically crashed into a hotel just 15 kilometers outside of Paris. All 100 passengers and 9 crew members on board lost their lives. It was an incredibly dark day that deeply shocked the entire globe and permanently shattered the invincible aura of the Concorde.
Section 4. The cost of supersonic. Economic downfall.
Now, while the crash was a horrific tragedy that immediately grounded the fleet for investigation, it also forced airlines to look very critically at the massive underlying flaws in the plane's design. The truth is, the extreme engineering required for supersonic flight had created a complete logistical nightmare. Remember that sonic boom we talked about? Well, it was excruciatingly loud. It became such a massive nuisance to residential areas that airlines had to heavily restrict the Concorde's routes, mostly keeping it out over the oceans. Second, the fuel consumption was just atrocious. It burned 4 times the amount of fuel compared to a normal passenger jet. Terrible for the environment, terrible for the wallet. And third, the maintenance. Keeping these highly specialized, bleeding-edge machines running cost British Airways roughly £1 billion every single year. So when you combine those astronomical running costs with plummeting ticket sales after the crash, plus the broader downturn in the aviation industry after 2001, the entire business model simply collapsed.
And so, Air France and British Airways were forced into a drastic decision. On October 24, 2003, the final commercial Concorde flight took to the skies. It's actually a pretty profound moment when you think about it. Usually, when we look at engineering and technology, it's always a story of forward progress, right? But the grounding of the Concorde represented a really rare technological regression. Humanity had engineered a way to fly civilians faster than the speed of sound, and then, for 2 whole decades, we just stopped. We literally went backwards.
Section 5. The future of fast. Return of supersonic.
But, human curiosity and engineering ambition rarely stay grounded for long. Engineers are actively working right now to bring this technology back, and more importantly, they're trying to solve the fatal economic and environmental flaws of the past. If we trace our journey with speed, it starts back in 1947, when Major Charles Yeager of the U.S. Air Force first broke the sound barrier in a military X-1 jet above the Mojave Desert. Fast forward to 1969, we get the first flight of the commercial Concorde. Then, that sad retirement in 2003. But look all the way at the end of the timeline, 2029. A new aerospace startup called Boom is currently building a modern supersonic aircraft, and major players like United Airlines have already placed orders for their new Overture jets.
What's so fascinating is how engineers are completely rethinking the problem this time around. Instead of chasing pure maximum speed at all costs, the new Overture aircraft is making a very calculated trade-off. It's going to fly slightly slower at Mach 1.7, compared to the Concorde's Mach 2.0. But in exchange for that slight dip in speed, the Overture is being designed to run entirely on sustainable aviation fuel, which is made from biodegradable materials. The whole manufacturing and operation process is aiming for net zero carbon emissions. And honestly, even at Mach 1.7, a flight from Dubai to Singapore that currently drags on for 7 hours would be slashed down to just 4. So I want to leave you with this provocative question to really chew on. Can net zero engineering and sustainable fuels finally make everyday supersonic travel a lasting reality? Have we actually engineered a way to fly faster than sound, connecting the globe in a matter of hours without destroying our environment or bankrupting our economy? Well, the engineering blueprints definitely say yes, but we're going to have to wait until 2029 to see if humanity is truly ready to break the sound barrier once again. Thank you so much for joining me on this explainer, and I hope this gave you a totally new perspective on the fascinating and